Rise and shine, porcupines. Guess what time it is? It's Algebra with Al time. I'm your host, Al Rosetti. Today we're looking at Chapter 1, Unit 6, solving compound and absolute value inequalities. So after watching this video, students will be able to solve compound and absolute value inequalities. The concept is compound and absolute value inequalities, the skills being able to solve them. So what do you say we get started? Here we go. All right, so first thing, let's talk about the graph, right, of an absolute value inequality. So how would I write the inequality for that? Well, the absolute value of x is less than or equal to 5. That's it. Look at number 2. So here you got two lines going opposite directions that don't connect. So it's going to be, right, x greater than, right? And it looks like it's at 7.5. Number 3. Absolute value of x less than 2.5. And number 4, absolute value of x is greater than 2.5. All right, number 5. Absolute value of x is less than 1. Number 6. Absolute value of x is greater than 4. Number 7. Absolute value of x is what? Less than 3. That's right. Less than or equal to because it's a closed circle. Almost forgot that. Absolute value of x greater than. No equal sign there. All right, so here we go. We're going to solve these and graph them. So the first, number 9, right, gives us two equations, but one's already solved. C is less than 0. So we only have to do the first part of this. And it's a simple two-step equation. That's the way you got to think about it. And in the end, you're going to graph it because it's inequality, but the steps are the same. So in the end, we have C greater than 2 or C less than 0. So we're going to go up to our graph. We're going to put a dot above 2 and above 0. Above the 0, we're going to go to the left. Above the 2, we're going to go to the right. So this is what we call an OR graph because they're going in opposite directions. If they were going at each other, we call that an and you'll see that here on this one here. So look at number 10. There's actually two equations in number 10 combined, and you have to be able to separate them. Well, it's pretty straightforward. You got 11 less than 4y, right, minus 3. That's 1. And then the second one is negative 3, is 4y minus 3 less than 1. Okay? Now, where do you start and stop? When you write the first equation, stop right in front of the second inequality. When you're writing the second equation, start right after the first inequality, and then you'll have your two equations. So we solve them both the same way, taking the inverses of each, and in the end, when we add 3, we have 4y, right? Less than or equal to 0, and then we divide by 4, we still get 0, okay? The second half of that, we add 3 to both sides, you get 4, divide by 4, you're going to get y less than or equal to 1. Okay, so now we're going to graph this, right? So let's look at the first graph. Remember, we read the graphs from the variable to the inequality. So that is y greater than or equal to negative 2. We don't read them from left to right. And the second one is y less than or equal to 4. So this is what we call an and graph. The two lines are coming at each other, they're connected, okay? So I just showed you 10 and 11 there, the answers to 10 and 11, and we're moving on to 13. All right, so once again, this is two equations given to you in one problem, and you have to be able to separate them. Where did I say start? Okay, stop on the first one. Stop right in front of the second inequality, so it's 8 less than 3x plus 2. And then the second equation start right after the first inequality, and you're going to get 3x plus 2 less than 23. Okay? So we do our math, subtract 2 from both sides, divide by 3, and keep it in mind, we read from the variable to the constant. This is x greater than 2, not 2 less than x, although it's just semantics, but if you do it that way, you're going to draw your arrow to the left, and it has to be to the right. All right, let's go to the other one. So on the other one there, we're going to what? we got to subtract 2, right, from both sides. And then we're going to, we got 3x less than 21, and we divide by 3, and we have x less than 7. Okay, so we're going to go up to the graph. We're going to put above 7, right? We're going to put an open circle, and we're going to go to the left, less than. Okay, the other one, x greater than 2, right? So we're going to have an open circle, we're going to go to the right. All right, number 14. So once again, okay, this is an OR, and it clearly says it on the paper. And so that means you don't have to separate them. Whenever it's an OR, they give you the 2 different equations. And then your graph, you know, will be 2 lines going away from each other. Okay, they will not connect. That's automatic with an OR. It's going to be this or that. All right, so the first one, we add 4 to both sides. We get w less than or equal to 14. The second one, all we have to do is a one-step inequality, subtract 2 or divide by -2. And w is less than or equal to -3. Now, remember, we divided by a negative, and since it's an inequality, we have to flip the signs. And once again, in Algebra 2, that's something that's automatic. You're not going to be reminded of that. It's just, you're expected to be able to do that. All right, so there you go. 15. Now this is pretty straightforward here. Although we're getting into absolute value, right? So the absolute value of t is greater than or equal to 3. Now, what do we got to do? We have to write, because it's absolute value, we write the expression twice. The second expression, we make the answer a negative number. And to do that, we have to flip the inequality. So we have t greater than 3 and t less than or equal to 3. So we're going to have open circles on both the 3's, and they're going away from each other. Okay? Going away from each other. All right, number 16. Here we go, another absolute value graph. So you know, first thing, you're going to write it twice. One just the way it is, one without the absolute value brackets, and then one, your answer is going to be negative, and that negative answer, you have to flip the inequality on it. All right, so divide by 6, we get x less than 2. The other one, we divide by 6, we get x greater than -2. So at -2, we're going to draw a line to the right, that's greater than. Okay, at +2, we're going to draw it to the left. So the actual domain in this and range would be all real numbers, because the lines do intersect. All right, absolute value of -7r is greater than 14. We're going to rewrite it, -7r, right, greater than 14, and -7r greater than or less than -14. So when we change the signs on the second expression, flip the inequality, it's automatic. Okay? All right, here we go. So -7r, divide by -7, you get r less than 2. Remember, flip the inequality, divide by negative. And here we go again, divide by negative. So we get r what? Greater than -2. Perfect. So at the 2's, open circles, both of them are going away from each other. +2 to the right, -2 to the left. All right, absolute value of p plus 2 less than or equal to -2. What do? We rewrite it without the brackets, p plus 2, right? Less than or equal to -2. Correct? Then what do? Well, if you did not recognize that there's no way that an absolute value inequality, because the absolute value brackets make everything positive, there's no way that it can be less than or equal to -2, then think about that, because that's when this is no solution. It's the only time that this absolute value inequality is no solution is when it is less than, not equal to, but less than a negative number. There's no way for that to happen, because absolute value makes everything positive. So this is actually no solution, number 18. Okay? And not because of the equal sign, because less than. It can be equal, but it can't be less than. All right, number 19, here we go. N minus 5 less than 7. So what do? We're going to rewrite it again. n minus 5 less than 7, just the way it is, and then n minus 5 greater than negative 7. Remember, flip the inequality on the second expression that you're going to change to negative. And then what? We add 5, it's a one-step inequality. We got n less than 12, and we got n less than 2, or greater than 2. So you got an open circle over 12 and 2, and they are going to the left and to the right. All right. Number 20. H plus 1 greater than or equal to 5. Absolute value. It's getting redundant. Rewrite it twice. One positive, one negative. Flip the inequality with the negative, and you got a simple one-step inequality to graph it. Okay? So, what's the key here? The keys are when you're doing absolute value inequalities or any inequalities, when you divide by negative, make sure you flip the sign. When you write your second equation, which is supposed to be negative, flip the sign right when you start. Now in solving it, if you had to flip the sign again, then you have to. But you start out on the negative with it already flipped. Okay? And that's all we have for you today. Boys and girls, thanks for coming. Appreciate it. And remember, math, math, math. Go out and do some math.